How you doing? Today we are in chapter 5 of volume 1 of the 8th edition of operational wastewater treatment plant. Today we're going to talk about secondary treatment, activated sludge. This may be a three-part series, two-part, I don't know. There's a lot to uncover in this chapter. I really feel like it could be a couple different chapters, but they made it into one big chapter, and so we're going to try to go through with it. So when we talk about secondary treatment, we talk about something that's after your grit removal process, um, after your primary clarification, and we're talking about activated sludge. If you do not know what activated sludge is, Google activated sludge tank. It is that brown mixed liquor. We call it mixed liquor. I know, weird name, but it's those biomass, what we call biomass, which is the microorganisms that we harvest in the tank, that we add air, that then processes the food or the organic matter, or what we'll call BOD, or ammonia. It The good bugs work to break down the organic matter, to condense it, to treat it, in that the fact that when we send it to the secondary clarifier, we want that settling feature where the clear water comes off, our microorganisms stay in our sludge, they settle down to the bottom of the secondary clarifier, and then ultimately we will waste that to our digesters. So the main things we're concerned about in activated sludge are BOD and total suspended solids. We call this suspended growth. This is different than like a trickling filter. Trickling filter, we usually uh, call that fixed solids. On page, or fixed treatment, on page 241, you can see a typical diagram of the activated sludge plant. You will hear me refer to return activated sludge and waste activated sludge. Return activated sludge is that sludge that settles in the bottom of the secondary clarifier, and then we return back to the head of the plant, or maybe through different parts without the aeration tank. Waste activated sludge, or WAS, is that part of the sludge when it settles, and you can see on page 241 that at the bottom of the secondary clarifier, some of it returns back to the head of the activated sludge tank, and some goes to the solids handling. When we harvest in that activated sludge, which is the brown, when we harvest that bacteria and that bio growth in that tank, it gets to the point where it gets too thick, and at some point we need to take some out of it. And when we do that, we actually return it back to the digester, that then processes it for land, um, and then the belt press, which we process for land application. The way it works at my plant is the wastewater comes through, it is aerated in the aeration tank, it comes in contact with the biomass, the bacteria, and then flows into the secondary clarifier. It settles to the bottom. A pump, or series of pumps, will pump it back up to the beginning of the aeration tank, and it starts the process all over. Every hour, we want to waste some, so we want to take a little bit out, because if we did not, it would get so thick that our clarifier, remember, we want to keep 1 to 3 feet in our clarifier. An actuator valve opens, and we send a part, we'll say 250 gallons a minute, we will send to the digesters. That valve will work for 10 minutes out of the hour, and it sends a fraction of that biomass that we're using to treat the water, a fraction that will go to the digesters, where once again we will turn that into biosolids to be land applied. On the top of 243, we look a typical approximation for bacterial cell composition is the formula CHONP. The formula details are not important. What is important is the microbial cells are composed of organic matter. The formula tells us for the microbes to grow, they need carbon as the building block and other nutrients such as nitrogen and phosphorus. When we talk, you'll hear us talk, and there's a um, definition of food to microorganism ratio. And what really we are describing there is the BOD is on top. That's the food. And the microorganism is that biomass, that mixed liquor, suspended solids, that brown um, liquid that you see in the tanks. It is the food versus our biomass. And we want to keep that ratio in a good state. If you have too much food and not enough, I'll call them workers, then your workers are going to get fat. If you have too much food or too little food and too many workers, what will you have is cannibalism. And so you'll have some death of your microorganisms. Secondary clarification, we talked about that last week, but that is a picture of a secondary clarifier. Once again, we want to try to keep a blanket on the bottom of that clarifier, but that's really where our biomass and the water separate. Our clear water will come to the top and our biomass will settle to the bottom, that brown mixed liquor. On page 253, please turn there with me. One of the desired goals is to maintain the aeration tank to produce flock forming bacteria, flocculate and settle the flock inside the secondary clarifier, and manage the activated sludge to maintain a healthy population of microorganisms in the system, particularly in the aeration tank. We are kind of like farmers in the wastewater industry. We are trying to keep our biomass healthy, um, and maintain the proper air ratio because we add blowers to blow the um, microorganisms and keep them suspended, but it also that is what uh, feeds feeds the microorganisms in the aeration tank. We talked about some collection systems uh, problems that if we have high uh, I, which on the bottom of 256 you see infiltration inflow is the total quantity of water, both infiltration and inflow without distinguishing the source. When we talk about infiltration, we're talking about that water that's coming in through manholes, through pipes. Inflow would be um, your gutter systems, maybe a sump pump. It's anything really outside of the ground or groundwater. I know I've had a test question on what's the difference between infiltration and inflow, so I think it's important that you uh, know the difference. On page 258, it says, therefore, an operator must be aware of and watch for potential collection system and septage hauler wastewater in terms of potential hydraulic surges or overloads, organic shock loads, toxic waste discharges, and septage with toxic or inhibitory materials, and take action to prevent upset in the activated sludge process. Your facility may accept septage or what we call tanker trucks. So in the rural areas, obviously people have septic systems and those need to be pumped. Well, they'll pump those and then haul those to your wastewater plant and discharge. Factories, they have vaults that need cleaned. Breweries have tanks and other equipment that will be cleaned. And so maybe your facility takes septage. And so this is just off-site waste that's coming in and being dumped at your plant, and you can charge them for that dump. But one thing that we need to be aware of is that it could possibly be toxic to our wastewater plant. Once again, knowing what they're hauling to you, maybe taking a quick ammonia test, quick pH test. Maybe you can do a COD test on the septage coming in. One, to build them, but also to know if you've got a hot load coming into your aeration. Because the one thing you don't want, just like as a farmer, you're trying to keep this flock healthy. And so if we have a shock load come in, we are going to kill our biomass, and it takes a while to get the biomass back up to the correct amount. On page 261, you see the total rate of food applied. That's that BOD, and the total microbial biomass. That's the mixed liquor, volatile suspended solids, and you can see that equation on 261. When we are talking about um, dissolved oxygen, dissolved oxygen, we want to keep it around 1 to 2 milligrams per liter in the aeration tank. That's what feeds our microorganisms. Um, I mentioned before that wastewater plant is very similar to a stream where that we have rapids and then eddies. And in that, what we're trying to do is clean up the water the way the nature does it, but in a faster manner. And so by adding oxygen to the tanks, that's supplying the energy that's needed to treat the mixed liquor. Let's talk about solids retention time and sludge age and MCRT. All these are basically we're looking for how long is that biomass going to stay in the system? How long is our sludge staying in the system before we waste it out? How many microorganisms are in there and how long are they going to be in there? And that will vary per the season. And so when we talk about MCRT, solids retention time, sludge age, basically how old is our sludge? How long has it been in there? And making decisions on um, how much to waste every day is an operator's main goal. Sometimes in the winter we'll bulk up the sludge a little bit or the mixed liquor suspended solids because the microorganisms are moving slower. And so we'll do that in the winter, sometimes in the summer, because of the oxygen um, demands. We will lower the mixed liquor suspended solids. SVI on page 269. The SVI is a parameter indicating the settability characteristics of mixed liquor suspended solids. An SVI is defined as the volume of solids in milliliter occupied by 1 gram of MLSS after 30 minutes of settling. And we're going to look at a settleometer test. That's something we do at our plant every day. Solids loading rate on 268. Solids loading rate is the solids is defined as the mass rate of solids in the mixed liquor applied per unit of surface area of the secondary clarifier. When we talk about blowers, um, we need to add this air to our aeration tanks. And so there's a couple different blowers that I want to mention on page 273. The three most widely used positive types in wastewater aeration systems are the centrifugal blower, the positive displacement blower, and the high-speed turbo blowers. So in the positive displacement, what you have is a piston, and as it pushes the air out. And so positive displacement is like a plunger type blower, if you want to think about it that way. And a centrifugal blower, it circles. And so it works just like a pump does, but as it goes around and around, it picks up air and sends it into the aeration tank. And then we also have the newer, not newer, but turbo blowers. My plant, we have all three. Well, we did away with centrifugal. We now have turbo and positive displacement. One thing that you need to know is that you can never shut down a positive displacement blower on the effluent side because that piston wants to go through. And if you shut down the discharge, you could cause a rupture to the positive displacement rod or mechanism. Centrifugal, you can slow it down on the discharge. I actually had centrifugal and I would slow it down so that the air would not be so much in the aeration tanks. Now, with the new turbo blowers we have, that's all automated and it's actually controlled off of DO probes. So when the tank, we want to keep it around 1 part per million. When the tank sees that the oxygen is getting lower than 1 part per million, it sends a signal back to the blowers. The blowers will then ramp up and provide more oxygen to our tank. In the wintertime, when oxygen is more condensed, it'll ramp itself down. And so technology's been really great. Back in the day, we used to do that manually by hand. So we'll talk about diffusers. Um, Picture 5.9. You can see that you have in 5.8, you can see that there are different types of diffusers down in the wastewater system. You have coarse diffusers and you have fine diffusers. Fine, you're going to get a better air to uh, water ratio. Coarse, you're going to get more of a bubble, but you're not going to have a better um, air contact. I don't know this for sure, but it kind of looks like in 5.9, it looks like in maybe an aerobic digester manifold, but it could be for um, it could be for an aeration tank. Uh, Interesting comment. I was down in an aeration tank installing new air diffusers during 9/11. And I remember an operator, just like this in page 275 at the top, an operator yelled down and said, "Hey, the Twin Towers have just been struck." And I thought he was kidding because he always listened to a shock jock, and I didn't think that shock jock could tell the truth, but he was. So Knowing that we do have um, those types of diffusers, I want to touch on page 276 and figure 5.11. That looks like in an oxidation ditch, possibly, and what an oxidation ditch is, and we'll go into it more, but it uses brushes that go down into the water, and the mixed liquor and the water get in contact with the air as the brushes go through the water. Environmental conditions on page 279. Temperature is an important environmental factor that affects microbial activity because microbes are active within a narrow range of temperature. In warmer temperature, microbes are more active and productive than in colder. Operators must maintain a higher level of biomass in the colder weather than in the warmer weather to treat the same amount of BOD. So once again, in the winter, we let our mixed liquor get thicker or more concentrate in our aeration tank because the microbes are less active to treat the same amount of BOD. Page 281, we've kind of touched on this already, but the basic requirement for an activated sludge process is supplying enough oxygen for biological oxidation of organic matter, thus maintain an aerobic atmosphere in the aeration tank. And it goes on in there and it says a DO level of 1 to 2 is typically maintained in conventional ASPs. ASP is activated sludge. 283, maintaining a sludge blanket. We want to keep that 1 to feet um, is most widely adopted. Yours might be a little bit um, different. You may want to keep it a little thicker, but we do that because we don't want the sludge to denitrify or gasify up. So we want to keep it as low as possible, but we still want to keep some in there. I think that it helps settle the sludge a little bit. Um, Sludge settleability control, activated sludge on page 284. Settleability is the characteristics of the sludge solid, indicating how well they settle in a secondary clarifier. This is monitored by determining the sludge SVI. In picture 5.17 on 287, that is that's a tabletop DO probe and a handheld DO probe. The one nice thing about a handheld DO probe is you can go out to the aeration tank and actually measure the different zones that are in the aeration tank to make sure that we are having enough oxygen in the tank and to make sure your fixed DO probes that are in the tank are calibrated. We once a week calibrate our meters to a handheld portable oxygen portable oxygen meter. That's something you would see in a lab. Turn over to page 292. Settability is how quickly the sludge will settle at the bottom of a secondary clarifier. The sludge volume index is a measure of the settability characteristics of the sludge. This test is performed in a cylinder called a settleometer. Sometimes a 1 liter graduated cylinder is used. So what we do is we have these clear jars and we fill those up and we let them set for 30 minutes and we just see how well the sludge settles in those clear jars. And this is an indication of what is going on in our clarifier. So every day we go out and we take a sample out of the mixed liquor aeration tank. We bring it in the lab. We throw it into a glass jar that is 1 liter, 1 to 2 liters, and we just watch it. We watch to see how it settles because we want to know if we need to make any changes to uh, our activated sludge. In picture 5.23, that's a sludge judge. And so what he is doing is that is a clear pipe that he is sending down to the bottom that has a check valve on it or valve. And you can see on the bottom of that, he actually has some sludge in there. And so that's how he's monitoring in the clarifier how many feet of sludge is in there. And so that picture is a good picture. I would guess those are 5 foot sections. So he has about 3 feet of sludge in his clarifier. As an operator, that's something we do all the time. Microscopic evaluation. Normally, some operators will take a sample of the microorganisms and run them under a microscope and see what predominant microorganisms we have. There are some microorganisms that we want in our system, and there's others that we don't want as much. And so doing an evaluation is important. The color of mixed liquor on 295. The color of mixed liquid should be light brown, indicating the correct balance of food and microorganisms. The mixed liquor color for young bacteria, which is whitish in color, darkens to a dark brown blackish color as the microbes experience too long of an SRT. So our mixed liquor should not be white, it should not be black, it should be brown, it should have an earthy smell. It should not have a ammonia smell or a strong pungent odor. It should have an earthy kind of just natural smell, really. If you're operating a wastewater plant without primary treatment, there should be little to no odors. I mean, my plant backs up to a subdivision, and so we really try to keep that uh, without odor. Record keeping, you know, keeping records of what you did in your logbook of how often you waste, when you wasted the mixed liquor suspended solids, your sludge characteristics, what you found in the microscope. That really helps, especially when you have different operators working at your plant. That way you can share that knowledge with each other. And so as operators, we need to be better at recording our data. I'm going to stop here for today and we are going to break down that chapter and we will be back on page 301 next time. Thank you.